Welcome everybody. We got a beautiful question, and this question serves two purposes. One, to show the power of geometry over algebra, and the next one, of course, the concepts that you are going to be learning. Now there is a semicircle that is actually inside a triangle. Now let me draw the triangle. Now this is a right angle triangle, and the hypotenuse side holds the diameter. So this is A, B and C. At C we have a 90 degree, right? So angle C is 90 degree. Now we are expected to find the shaded region. So this region is required. Okay, so this is the required area. So we need to get this. Now we are given AC is 6 units, BC is 8 units, AB is 10 units. So this is given, and we have to, as I mentioned to you, we are required to get the shaded regions area. Now there is a tangent at D and a tangent at E, right? So there is a tangent at D and a tangent at E. Okay, so what I'm going to do is I'm going to use the all-important theorem. Now if I were to draw, the statement is, if a line is drawn from O to, which is the center of the circle, to the tangent to the circle, the angle made will be 90 degrees. So if you were to draw a line from O to the tangent, the angle made is going to be 90 degree. Now I'm trying my best to represent the content or to represent the concepts. The figure is little bit not to the expectations. So the most important thing that you have to know is the concept that is being displayed here. Okay, so as I mentioned to you, a line is drawn from O to D. So this is going to be, by theorem, this is going to be making 90 degrees. So that is 90 degree there. Now I can repeat the same thing, a line being drawn from the center O to the tangent, right? Now let me do that. Okay, the figure is fairly fine. So this is going to be making 90 degrees. So you have a 90, you got a 90 here, right? Now I've already mentioned to you, angle at C is 90. So this is 90. So this is 90, this is 90, this is 90. You get 3 90s, and you know that ODCE is a quadrilateral. So let me state that. We see that we observe that ODCE is a quadrilateral. So the sum of the angles inside will have to be 360, but angle D is equal to 90, angle at E is equal to 90, and angle at C is equal to 90. So this means angle D plus angle E plus angle C plus angle at O. But we know that all of these angles should be equal to 360. So you put this angle 90 plus 90 plus 90 plus angle at O should be equal to 360. So this means angle at O should also be equal to 90 degrees, right? Only if this is 90, it will add up to 360. This is the requirement for a quadrilateral. So this is clearly 90 degree, right? So if all the four angles are 90, what are we talking about? The angles are all 90. So if I were to take OE is R, this is also going to be R. So because of the fact that each of these angles are 90 degree, we are talking about a square. So that would mean this is going to be R, this side is going to be R. Now our requirement is to find the radius. So if we can find R, the question is solved. Now the all important point here is we are given AC is equal to 6 units. So this entire thing is given to be as 6 units. If this is 6 units and this is R units, this should be 6 minus R. This entire length is given to be as 8 units. This entire length is 8 units. This is equal to R. So this is going to be 8 minus R. Now this entire length is given to be as 10 units. So if this entire length is 10 units, then we will have to actually extract the values of R from here. Now we cannot do any deductions of the measurement here. We have to just simply take AB to be this entire length to be as 10 units and then work out our way to getting the value of R. Okay, so what I am going to be doing, I am going to be showing you two ways. One is by the way of geometry, the other is the way of algebra. So you can pick the way that you want. Okay, so I mentioned that our requirement, our objective, our requirement is to find R. That is our priority. So if I get R, the question is solved. So what I wish to do is, I would like to draw your attention to two triangles that are present here. Now you got a triangle ADB. Now I just mentioned to you that this angle is 90 degrees. So if this angle is 90 degrees, so for sure, let me just highlight this with a different color. So this is going to be 90 degrees, right? So if this is 90, this is going to be 90. Now what I wish to show here is, if I were to take this to be as, say, some alpha and this to be as some beta, then if I were to consider, let me write this down, consider triangle, it's a right triangle, triangle ADO, right? So what is the observation that you see here? We observe that alpha added with beta should give us 90 degrees. So this and this should give us 90 degree. So this is 90 degree, this is beta, this should be alpha, this should be beta. Also, what do we observe? Angle at A is equal to alpha. If you were to consider triangle ADO, and I'm adding a small one more joint there, and triangle OEB. So in both the cases, alpha with beta will be 90. Alpha with beta will be 90. So angle A is alpha. Then angle at O is also equal to alpha. Angle at B, this part of the B, is equal to O, and I should say angle at O. Angle at O is equal to beta. Angle at O is equal to beta, and similarly angle at B is equal to beta. So what are we talking about here? We are talking about two similar triangles. Clearly, and one important fact, angle at D over here is equal to angle at E. Angle at D is 90, angle at E is equal to 90 degrees. So clearly, what do you observe? Clearly, we observe that triangle ADO and triangle OEB are similar triangles. Right, now this is the all important concept that we know that we have to use. Now if these are similar triangles, then this means AD over OE is equal to OD over EB. Right? Of course, you can also get another ratio, but it's enough for me that I use this ratio. AD over OE is equal to OD over EB. Now what is AD? Go to the diagram. What is AD? AD is 6 negative R, so this means 6 negative R divided by OE. OE is going to be R is equal to OD. OD is equal to R divided by EB. EB is 8 negative R. So we will have to solve this. So I cross multiply. So if I cross multiply, let me use this part of the space. So 6 negative R times 8 negative R is equal to R squared. 48 negative 6R negative 8R negative positive R squared is equal to R squared. Right? So this would mean R squared can be cancelled. So I can rewrite this as 48 is equal to 14R. Let me use 2 times. So R is equal to 48 divided by 14. 2 divides here 7 times, 2 divides here 24 times. So you get 24 over 7. This is equal to R. So this is the value for R. But we need to get the area of the shaded region. Right? So the area of the shaded region, let me complete the question here. Required area. Required area is equal to area of the square. Area of the square. From the area of the square, you take away the sector area minus sector area. So I need to go to the new page because it would give us some room to work out. So what is the area of the square? Area of the square is side into side. So the side is r units, and 24 over 7. 24 over 7 multiplied with 24 over 7, which is 24 over 7 whole squared. Now sector area. Sector area is equal to theta divided by 360 multiplied with pi into r squared. Okay, so this is the formula. So what is theta? Now clearly we have found that to be 90 degrees, right? So 90 degree divided by 360 multiplied with pi times 24 over 7 whole squared. So 9 divides here 4 times, so pi over 4, and I can write 24 over 7 as 24 over 7 squared as 24 over 7 times 24 over 7. 4 divides here 6 times. So this is going to be 6 4s are 24, 2 6 2s are 12, 13, 14. 144 divided by 7 times pi. So therefore required area is area of the square 24 over 7 squared negative 144 over 7 times pi. So this is what I've got. Now what I can do is, now I can write this as 24 over 7 times 24 over 7 negative 144 over 7 pi. I can take a 7 out, I can take a 24 out. This is going to give me 24 over 7 minus 24 divides 144 6 times. 6 4s are 24, 2 6 2 are 12, 13, 14. So that's 6, and 7 is already taken out, so you get a pi there, right? So this is the required area, square units. Now if you want, you can utilize a calculator and simplify and get an approximate answer. If not, you can just leave it as it is. So this is going to be the complete solution. So I will now show you how this is done, how the value of r is calculated using algebra.